Oh, parts of similar triangles, like the medians, the altitudes, and the angle bisectors. Thank you, Alexiana. Someone needs to keep me on my toes. And then 7-6 is going to be your favorite. If you don't pay attention, then it's going to be your least favorite. It could potentially be your very favorite one, though, because it's the easiest of the three, in my personal opinion. But I also paid attention in math class, so you know. It is what it is. Okay, someone help me with a bell ringer. What is something I could factor out of this expression?
4.
Okay, a 4, and then what else? M, N, and what would I be left with?
8N7 plus N5.
Would it be negative 8?
Yeah. Yes.
N7 plus M5
Plus
into the 5th plus what?
3 into squared or no.
Into the
3.
into the 3rd. And then plus what?
4.
Plus 4. Okay, I saw Caitlin raise her hand, and I purposely did not call on her because I'm pretty sure, because Caitlin's is taking algebra 2 trig, that she factored out a negative 4 MN, because we would like for that first term to not be negative. Just FYI for those going on to the next class. In geometry, the fact that you can factor out the 4 MN is really all I need from you. Okay, someone make me proud though, so that's an algebra skill. Someone make me proud and remember this formula for a trapezoid. Yes, ma'am?
The formula would be the base 1 plus base 2 divided by 2 equals mid-segment.
Mid-segment. Okay, I did not get a chance yesterday to read your justification answers. I did not. But yesterday's Bowen question was asking about the mid-segment of a triangle. So if I were you, I'd make sure that key word was in my response. For some reason, some in first and second period put the word mid-point instead of mid-segment. If you put the word point, that implies a point. Segment implies a segment. Make sure you're using your geometry terms correctly, or else they're going to think you don't understand geometry, and you do. Okay, so if I plug stuff in, I have 6x plus 4 plus 10x minus 2, all divided by 2 equals 5x plus 10. I did base 1, that was 6x plus 4. I did base 2, that was 10x minus 2. I divided by 2, and I set that equal to my mid-segment, which was 5x plus 10. What should be my next step on this problem? Okay, let's clean it up like Ms. Brewster said. I heard 2 different things. Yes, dear. We'll do what you say. See, every class period said that. Juliana, you're the only one who did what I would have done first. But every class period said that, and it's going to work, Kayla, let's do that. If we multiply everybody by 2, the denominators cancel out. And you'll have 6x plus 4 plus 10x minus 2 equals what?
10x
plus 20. That's what I wanted to know. Dylan remembered how to distribute. If you don't distribute, specifically when we cross multiply with a proportion, you're blowing this chapter, I bet, the way you did the last one. Okay, if we combine our like terms, we have 16x plus 2 equals 10x plus 2, 20, 10x plus 20. If I subtract 10x, I have 6x plus 2 equals 20. Minus 2, I end up getting 6x equals 18. So what's my final answer? X equals 3. Yay. Awesome. God forbid we do math in math class. I know it's worse. The worst. Okay. So if you've got all that, I'm really impressed. Today we're going to do what will be your favorite of the 3 sections for this chapter. We are going to talk about something you will love. Now, I'm not a betting woman, but if I was, I bet so far if you had to pick your favorite section from this class, or what I would call the easiest section, it would be the one on translations, rotations, and reflections. Because that was pretty easy. We liked that one. It was pretty good. Guess what? That was a kind of transformation. And this is a transformation that we're talking about today. So that means you like it. It's like a rotation, a reflection, or a translation. It's on that same plane. The only thing different is those three were congruence transformations, meaning the shapes had to stay the same size. This is a similarity transformation. So the sides are proportional and the angles match. Okay, so today we're going to talk about a different kind of translation. We're going to talk about a dilation. What part of your body do you have dilated? Your eyes. Okay, I don't know why I put that big of a space between my O and N, but I did. A dilation. And what happens to your eyes after they've been dilated?
Become bigger.
Okay, so they can either be enlarged, which would be an enlargement, or they can get smaller, which would be a reduction. So we're going to be given an original shape. We're going to have to ask, did it get smaller or did it get bigger? If it got bigger, it's an enlargement. If it got smaller, it's a reduction. That part seems pretty easy. So let's look at our first example. They say A is the original and determine if from A to B is an enlargement or a reduction. So was it an enlargement or a reduction? It got smaller, so it's a reduction. That's half the battle today. Enlargement, reduction. Ma'am. I know, I'm going to come back to it. Okay, so Kaylee wants me to go back to the blank I've left out, which is my next bit. What have we calculated every single section of Chapter 7? Yeah, she said it so fast it was perfect. The scale factor of a dilation. And then they explain what it is. It's a ratio. It's still where you compare the two sides that are supposed to be similar. We should get the same scale factor for all of the sides on our similar shapes. And then here's the trick for Ryan. If it's a reduction and things were getting smaller, you should have a small scale factor. So you should have a fraction. A reduction should be a fraction scale factor. Less than 1. If you're getting bigger, like when you supersize your meal, it's getting larger, so your scale factor should be bigger than 1. So if I write the word reduction for our first example, what kind of answer am I expecting?
Less than 1.
I'm expecting a really tiny fraction. So you're going to know if you've gone wrong if you don't get a really tiny fraction. Okay. I know. So do you remember how we used to count things? So if I count the distance on the bottom of A, if I count how many blocks I've moved over total, it would be 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. Does everyone understand how I got 6? Okay. Then how long is the bottom of B?
3.
Yeah.
1, 2, 3. It is 3. You don't count the first one. It's like, how many blocks did I cross? I crossed 1 block, 2 block, 3 blocks. So it's 3. Okay, so then over here, does Miss Compton put 3 over 6, or does she put 6 over 3? 3 over 6 is correct. Again, I understand a reduction is supposed to be a small fraction. And then my hint to you is that I always put A in the denominator. Because every problem we work, A was the original guy. I always put the original guy in the denominator.
That's all?
That's all. I have to do it for all 3 sides. Okay, so we need to count. We counted the horizontal side. Let's count the vertical side. How long is it on A?
4.
How long is it on B?
2.
So 1, 2, 3, 4, 1, 2. So I'm going to do 2 over 4. Which, lo and behold, also reduces to 1/2. Awesome. Are there any questions so far? I'm just counting blocks. Okay. Well, then my geniuses get to that third side because we need to make sure it works for the third side. We do. So my true geniuses we'll just use the distance formula between this point and that point, and then between this point and that point, because they know the distance formula, they like it, they're good at it, they'll use it. My medium geniuses are going to do something along these lines. There is a trick to the distance formula. If we want to count from here to here, I need to know how many up and how many over. So how many did I go up?
3.
1, 2, 3, 4. How many did I go over? 4, 5, 6. Is it 6 or 7? 1, 2, 3, 4, 5, 6. 6. So 4 and 6. I'm going to actually do my lesser geniuses first. Okay, let's do the same. Don't put 10. Just leave it at 4 and 6 for there. Okay, let's do the same thing. Up and then over. How many up did I go?
2.
How many over did I go? Did you realize 2 over 4 is 1/2? And 3 over 6 is also 1/2? But then I'm doing double the work for that one side. Can you just leave it there? So my medium geniuses are going to do this. Well, my super geniuses are going to distance formula it, prove it to me. My medium geniuses are going to do this to show it to me twice. And then my lesser geniuses, if you'll leave your picture exactly like you had it, that shows me that Cassie understands it, because she knows 4 divided by 2 is 2. She knows 6 divided by 2 is 3. So she's got this regardless. Okay, everyone good with this? Are there any questions about this? Okay, so then we're going to go on to example 2. Why is this second one easier?
Because it's an enlargement.
Okay, why? Say it again.
It's an enlargement.
Well, it is an enlargement. Why is this one going to be easier? Okay, do I have to do any of this voodoo magic Miss Compton just did?
No.
There's no slanted sides. There's no slanted sides. So this is going to be easier. Also, for my slightly advanced geniuses, if you still want to do the distance formula, I can still use those numbers. It's 4 squared plus 6 squared. And that's one of them. And it ends up being square root of 52. And then 2 squared plus 3 squared ends up being square root of 13. And square root of 13 over square root of 15 ends up being 1/2. If you're wanting to be more mathematical in it, it's still 1/2. Again, any attempt of what I did in purple, Ryan's going to get his points. Okay, so B is a lot easier because there are no slanted sides. You're hoping for pictures with no slanted sides. So let's look at our second one. How long is, Brianna had it first. Is it an enlargement or a reduction? Let's start there. Okay, it got bigger, so it's an enlargement. So what kind of number are we expecting?
A big one.
A big one. So we're not wanting like 1/2, we're wanting 2 or something like that. So how long is A on the bottom?
So 2, 1.
It's 1, 2, right? We went over 2 squares, so 2. How long is B on the bottom?
6.
1, 2, 3, 4, 5, 6. She's right. So I have 6 over 2. What does that reduce to?
3.
3.
Wow.
Okay, so let's check all the other sides. On the top, again, it's 2. All the way across on the top, again, it's 6, because it's a rectangle, so of course this is going to happen. So 6 over 2, which is 3. So the top and the bottom work, and now we got to check the sides. What should I put in my fractions for the sides?
3 over 1.
1 on bottom, 3 on top.
Because it's 1, and then, because I went over 1 on each of the sides of A. And then on B, I went up 1, 2, 3. 1, 2, 3. So I'm going to have 3 over 1, which again reduces to 3. So it's an enlargement, and my scale factor is 3. Are there any questions so far? Okay, so we still have one example left, but I want to flip to the back really fast. Obviously, you love 2 But 3, oh no, slanted sides. 1, oh no, 1 slanted side. And then 4 is the worst of them all. Why is 4 the meanest?
It's not inside of it.
Because it hits at weird numbers. For instance, this number is 2.5, negative 2.5. So as long as you try that one, I'm going to give you your points for it. All the ones on the test. No, try. Meaning, will at least count the straight, flat sides and just say that's the answer. Yes, he can. He is that good.
I don't think I'm that good.
He is. He can at least find the skill factor on the sides he can count. And then there are some at the bottom where you actually have to graph. And while that's good and important, and of course you should try it, the 2 that I put on the test, because I made the test this morning, so that's currently on my mind. The 2 that I put on the test are already graphed for you, and one of them is a rectangle, meaning all the sides are nice and easy and countable. Okay, are there any issues with the worksheet before we go finish the front? Okay, if you flip it over, we have one last problem left. And the only reason it is hard is because of that very first word behind the word example 3. It's that word verify. So in all the other problems, we didn't have to prove things. In this one, we're supposed to prove something. What do we use when we prove something? Okay, and what are the 3 we've been using with similarity? I erased them earlier. We did SSS. We did side, angle, side, and there was a third one, angle, angle. So we need to argue one of those for this to work. So just keep that in the back of your mind. I'm going to write them down. SAA, SAS, SSS. I'm going to try to use one of these in this problem somehow. Okay, and then a letter's missing. It needs to be an N. It's cut off. Okay, which was the original we need to read? Was MNO the original or DFG?
MNO.
Okay, so in that case, was it an enlargement or a reduction? Reduction. So you know we're looking for a fraction kind of answer. We can count MN. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did everyone else get 12?
Yeah.
Is MN 12 on the bottom? Lord, I hope so. If someone else gives a different number, let me know. Okay, and then I need to know how long DF is on the bottom. 1, 2, 3, 4. I think 4, 2. So I have 4 over 12. What does that reduce to?
Equals to 1/3.
That's 1/3.
I thought that was like the division sign too.
Sorry. 1/3. So we've checked one side. That was an easy side to check. Let's check the other easy side. So I need to know how long MO is. I need to know how long GD is. When I said GD in second period, for some reason they started laughing. I don't really know. I knew it would happen in here if I pointed it out.
What was it, GD?
So what did you end up getting for your fraction? Miss Brister's got it. 3 over 9. Does that reduce to 1/3? Okay. So I got some options. Yes, dear.
Couldn't you just say that D and M are right angles?
I have been waiting for you my whole life in some ways. Yes. So if you want to be a smarty, you could argue that they have an angle in common. So you could stop here and argue that they're similar by side, angle, side. Juliana is correct. We could argue that there is a right angle here and a right angle here. And so since we found the scale factor twice and the angle in between they share, it's side, angle, side. This is true. Do most people think like Juliana? No. No. I would have to count the third side and make sure it was legit and argue side, side, side. So let's see. Up 1. I got to go up and over. I went up 1, 2, 3, 4, 5, 6, 7, 8, 9. I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 9 over 12, hey, that's still 1/3. So I'm still looking good. but I think I gotta count up 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Ooh, did I count wrong?
There's 4.
9 over 12 reduced over 5.
No, we were just the 3/4. I need to check my math today, Miss Brister. Where? I know. So you got 3. What'd you get? 3 and 4. Okay, so I don't know what Miss Compton was thinking because I'm not supposed to be comparing those numbers anyway. So I got 4 here and 12 here and 3 here and 9 here. So if I'm comparing the two that went up, I went up 3 on the tiny one. I went up 9 on the big one. So it's 3 over 9, which is 1/3. If I compare, like I went up 3 on this one, I went up 9. I went over 4, I went over 12.
Did you do 9 over 12?
I did, it was wrong. That was me being wrong. I've been wrong before, I'll be wrong again. So if we want to compare, we went up 3, we went up 9. 3 over 9 is 1/3. We went over 4, we went over 12. 4 over 12, also 1/3. So technically Ryan has his third S doing this. Or he can be a fancy pants and actually use the distance formula. Or he can be an even fancier pants and try to argue that they share an angle so he doesn't have to calculate that third side anyway. Before I butchered it there at the end, were there any questions? Okay, so now that Miss Compton's done it her way, I can argue side, side, side. But do I have to do all that? No.
Well, you could just count it up and count it over and see that there's a 4 on the top and a 4 on the bottom and a 3 on the side and a 3 on the side and the rectangles.
Yeah, it's a rectangle. Yeah, that would work too. But not everyone's seeing the 3D picture like you, so
Smart.
yeah, not too smart, just in a league of your